November 14, 1942. Rabaul Harbor, New Britain. Captain Hiroshi Yamamoto stood on the bridge of the destroyer Hayashio, watching the morning supply convoy prepare for departure to Guadalcanal. His communications officer, Lieutenant Kenji Tanaka, handed him the intelligence report that had arrived during the night from Combined Fleet Headquarters. "The Americans have deployed twin-engine fighters to Henderson Field," Yamamoto read aloud, his voice steady with confidence. Aircraft designation: P-38, Lightning. Twin booms. Concentrated nose armament, estimated at 4 machine guns. He folded the document and placed it in his jacket. Another American design mistake. Heavy fighters cannot threaten warships. Their guns lack the power to penetrate naval armor. What Captain Yamamoto did not know, what none of the Imperial Japanese Navy Command could comprehend, was that at that very moment, 150 miles southeast over the Solomon Sea, Major Richard Bong was leading his 431st Fighter Squadron toward the Japanese convoy. His Lockheed P-38 Lightning carried not 4 machine guns, but one 20mm cannon and 4 50-caliber machine guns, all concentrated in the nose for devastating anti-shipping firepower. The mathematics of naval destruction were about to be rewritten by an aircraft that Japanese naval doctrine said could not exist. While Japanese fighters carried light armament suitable for aerial combat, the P-38 packed ship-killing firepower into a platform that could attack from any angle at any altitude. A single concentrated burst could penetrate destroyer armor and detonate magazines. What the Japanese destroyer captain could not grasp was that he was not just reading an intelligence report. He was witnessing the death sentence of the Imperial Japanese Navy surface fleet, written in the most decisive language of modern warfare: concentrated firepower delivered by aircraft designed specifically to sink ships rather than merely damage them. The Japanese confidence in November 1942 was not mere naval tradition. It was based on mathematical certainty derived from centuries of experience. The Imperial Japanese Navy had dominated Asian waters since the Russo-Japanese War of 1904 through 1905. Their surface vessels had achieved victory ratios that established Japanese naval supremacy across the Pacific Ocean. At the heart of this dominance stood Japanese naval design philosophy, which emphasized speed, maneuverability, and concentrated firepower in surface combat. Japanese destroyers like the Hayashio class carried torpedo armament that could sink any Allied warship in single salvos. Their crews were trained to close range rapidly and deliver devastating attacks before enemies could respond effectively. Admiral Isoroku Yamamoto, architect of the Pearl Harbor attack and Japan's foremost naval strategist, had personally overseen the development of Japanese anti-aircraft doctrine. His philosophy was simple: fighters attacked fighters, bombers attacked ships. No single-role aircraft could effectively perform both missions without fatal compromises in design. The statistics seemed to support this confidence. Japanese destroyers typically carried between 6 and 12 anti-aircraft guns, ranging from 25mm to 127mm caliber. This defensive armament had proven effective against conventional torpedo bombers and dive bombers that approached on predictable attack profiles. Japanese naval architects believed American twin-engine fighters represented fundamental misunderstanding of naval aviation requirements. Carrier-based aircraft needed to be lightweight for deck operations. Land-based aircraft needed extreme range for Pacific distances. No aircraft could optimize both characteristics while carrying effective anti-ship armament. Intelligence reports from early P-38 encounters seemed to confirm Japanese superiority. The aircraft was fast and heavily armed, but too large for carrier operations. Its twin-boom design suggested structural weakness under the stress of high-speed maneuvering. Most importantly, its armament appeared optimized for air-to-air combat rather than ship attack. The Japanese dismissal of concentrated nose armament against ships stemmed from technical doctrine developed through decades of naval warfare experience. Anti-ship weapons required large-caliber guns or torpedoes to penetrate armor and cause significant damage. Machine guns and small cannons could damage superstructure but could not sink warships. Commander Taimichi Hara, one of Japan's most experienced destroyer captains, briefed his officers on American fighter capabilities. After early encounters near Guadalcanal, the P-38 is fast and well armed for fighter combat, but concentrated machine gun fire cannot penetrate destroyer armor, maintain anti-aircraft fire, and execute evasive maneuvers. The Japanese assessment was not entirely wrong. Early P-38 anti-shipping attacks had achieved limited success against heavily armored targets. Japanese destroyers had absorbed machine gun fire and continued operations. The concentrated armament was impressive, but seemed inadequate for naval warfare, where armor protection was specifically designed to defeat projectile weapons. But what Japanese naval intelligence failed to grasp was the fundamental difference in American tactical development. While Japan pursued traditional surface combat between armored warships, America was developing systematic destruction of unarmored critical systems. The P-38 was not designed to sink ships through armor penetration, but to destroy them through critical system elimination. At Lockheed Aircraft Corporation, designer Clarence Kelly Johnson had created something unprecedented, a fighter aircraft with sufficient firepower concentration to destroy naval targets through precision rather than brute force. The nose-mounted armament could penetrate critical systems that armor could not protect: radar, communications, fire control, and propulsion. What they did not know was that across the Pacific, American naval aviation was not thinking about traditional ship versus ship combat. They were designing aircraft to eliminate Japanese naval effectiveness through systematic destruction of critical capabilities rather than complete vessel sinking. The transformation began on October 26, 1942, when the 5th Air Force received authorization for dedicated anti-shipping missions using P-38 aircraft. General George Kenney, commanding Allied air forces in the Southwest Pacific, was ordered to develop tactics specifically for destroying Japanese naval transportation. Major Richard Bong became the architect of this revolution. A former flight instructor who understood the vulnerability of mechanical systems, he developed what became known as ship-busting tactics. His philosophy was direct: concentrate maximum firepower on critical systems and eliminate vessel combat effectiveness without necessarily sinking it. The Lockheed P-38 Lightning represented everything Japanese naval doctrine opposed. Instead of distributed anti-aircraft armament, it concentrated one 20mm cannon and 450 caliber machine guns in the nose. The combined rate of fire exceeded 3,000 rounds per minute, all focused on target areas measured in square feet rather than square yards. The concentrated firepower that Japanese naval architects dismissed as insufficient proved to be revolutionary. Unlike conventional aircraft weapons that created scattered damage across large areas, nose-mounted armament converged at single points. Every round fired struck within inches of every other round, multiplying destructive effect exponentially. But the true revelation lay in the P-38's precision anti-shipping capability. The concentrated nose armament could penetrate bridge armor, destroy radar systems, sever communication lines, and disable propulsion with surgical accuracy. Japanese warships, designed for armored combat rather than precision attack, proved vulnerable to this focused firepower. The first major demonstration came on November 14, 1942. During the naval battle of Guadalcanal, the 431st Fighter Squadron encountered the Japanese destroyer Hayashio, escorting a supply convoy to Guadalcanal. What followed would revolutionize American anti-shipping doctrine forever. Major Richard Bong, flying his P-38 Marge, approached the destroyer from the stern quarter at wave-top altitude. His concentrated armament fired for exactly 4 seconds, delivering 200 rounds directly into the ship's superstructure. The 20mm cannon shells penetrated the bridge, while 50 caliber rounds destroyed radar and communication equipment. The destroyer did not sink immediately, but it became combat ineffective within seconds. The bridge crew was eliminated, radar systems destroyed, and communications severed. The ship could no longer coordinate with other vessels or defend against subsequent attacks. Follow-up P-38 strikes finished the destruction process. Japanese damage control teams had never encountered such concentrated precision destruction. Ensign Saburo Hayashi, one of the few survivors from Hayashio, recorded his observations in a report preserved in Japanese naval archives. The American fighter did not attempt to sink our ship with single massive attack. Instead, it systematically destroyed every critical system until the vessel became helpless. By December 1942, P-38 squadrons were systematically targeting Japanese naval vessels throughout the Solomon Islands campaign. The aircraft's long-range, heavy armament, and twin-engine reliability made it ideal for extended anti-shipping patrols across vast Pacific distances. The tactical advantage was mathematical. Japanese destroyers required multiple torpedo or bomb hits to be sunk through conventional attack methods. The P-38's concentrated armament could eliminate combat effectiveness with single strafing runs lasting less than 10 seconds. Every burst guaranteed mission success. Rather than mere damage, Japanese naval operations began reporting unprecedented loss rates of combat effectiveness. In December alone, Combined Fleet Intelligence documented 23 destroyer and cruiser disablements attributed to American fighters. The pattern was consistent: concentrated nose fire resulting in total system failure rather than repairable battle damage. If you are amazed by these incredible precision attack statistics, make sure to subscribe and hit the notification bell. We are just getting started with the most devastating naval aviation story of World War II. The December 20th attack on the Kagero-class destroyer, Hamikaze, demonstrated the P-38's strategic anti-shipping impact. Lieutenant Colonel Charles MacDonald led 12 Lightnings in a coordinated attack on a Japanese cruiser formation. Approaching Guadalcanal with reinforcements and supplies, the lead cruiser was struck by concentrated fire from 6 P-38 aircraft firing in sequence. The 20mm cannon shells penetrated the bridge and fire control systems, while 50 caliber rounds destroyed radar and communication equipment. The cruiser became blind and mute, unable to coordinate defensive fire or communicate with escorting vessels. More significantly, the attack demonstrated psychological impact beyond immediate physical destruction. Japanese naval crews began refusing duty assignments on vessels operating within range of Henderson Field. Surface operations became irregular as commanders avoided areas where P-38 attacks were likely. Lieutenant Kenji Tanaka, the same communications officer who had dismissed American fighter capabilities 2 months earlier, witnessed the aftermath of the cruiser attack. His report to Combined Fleet Headquarters revealed growing alarm. The American fighters do not simply attack our ships, they eliminate their ability to function as warships. The concentrated nose armament creates system failures beyond our repair capabilities. January 1943 brought systematic P-38 campaigns against Japanese naval supply lines. Operation Clean Slate targeted shipping networks supporting Japanese garrisons throughout the Solomon Islands. The concentrated firepower proved devastating against merchant vessels that lacked warship armor protection. The 431st Fighter Squadron destroyed 31 Japanese merchant vessels during the first month of operations. Each ship required an average of 12 seconds of concentrated fire to achieve total system failure. Japanese replacement rates could not match American destruction rates. Shipping capacity declined despite maximum construction efforts. The mathematics were becoming undeniable. A single P-38 could eliminate more Japanese shipping capacity in one mission than Japanese shipyards could replace in a month. The concentrated armament multiplied destructive effectiveness far beyond conventional anti-shipping aircraft capabilities. Japanese countermeasures proved inadequate against the P-38's advantages. Anti-aircraft guns could not traverse fast enough to track high-speed, low-altitude attacks. Fighter escort was limited by the Lightning's operating range and the brief duration of shipping attacks. Most importantly, the damage was so precise that prevention became more critical than defense. February brought the revelation of P-38 anti-shipping tactics refinement. American pilots discovered that concentrated fire into ship bridges created command and control failures that eliminated vessel effectiveness even when propulsion remained functional. The psychological effect was enormous, as Japanese crews understood that survival depended on abandoning ship rather than fighting. Naval operations shifted to nighttime schedules to avoid P-38 attacks, but the Lightning's twin-engine reliability and primitive radar capability allowed night operations that single-engine Japanese fighters could not match effectively. American pilots, using improved navigation techniques, continued destroying Japanese shipping, even in complete darkness. The technological gap extended beyond firepower to operational capability. Japanese fighters required perfect weather and daylight for effective anti-shipping missions. The P-38's twin-engine redundancy and instrument capability allowed operations in conditions that grounded conventional aircraft. Weather became an American advantage rather than mutual limitation. March 1943 brought systematic destruction of Japanese naval construction facilities. P-38 formations attacked shipyards with the same concentrated firepower used against individual vessels. The Mitsubishi Heavy Industries shipyard at Nagasaki was struck by 48 Lightnings firing simultaneously, creating industrial damage that required 8 months to repair. The attack demonstrated strategic application of concentrated firepower against naval production capacity. Instead of dispersing attacks across multiple targets, American commanders focused maximum firepower on critical construction bottlenecks. The destruction of shipbuilding capability proved more effective than sinking individual ships because replacement became impossible. Technical analysis of destroyed Japanese vessels revealed the devastating effectiveness of concentrated nose armament against naval targets. Unlike wing-mounted weapons that created scattered damage across superstructure areas, the P-38's nose guns created concentrated destruction in critical command and control systems. Ships could not function with bridge penetration, regardless of hull integrity. Japanese naval engineers, studying wreckage patterns, discovered that concentrated 20mm cannon fire could penetrate destroyer bridge armor at any engagement angle. The high rate of fire meant multiple hits within seconds, overwhelming structural protection. Designed for single large-caliber impacts, repair became impossible because critical systems were completely destroyed rather than damaged. April 1943 brought spring operations that demonstrated the P-38's all-weather anti-shipping capability. While Japanese fighters remained limited by weather conditions, Lightnings continued destroying naval targets, regardless of visibility or sea state. The twin-engine reliability that Japanese designers had dismissed as unnecessary proved decisive in sustained naval campaigns. The psychological impact on Japanese naval personnel became strategically critical. Ship crews began abandoning vessels at the first radar contact with approaching aircraft. Naval officers refused command assignments on vessels operating within P-38 range. The surface fleet began failing due to personnel shortages rather than equipment destruction. Captain Hiroshi Yamamoto, the same destroyer commander who had dismissed American fighter capabilities 8 months earlier, now faced the mathematical reality of Japanese naval defeat. His final report to Combined Fleet Headquarters was classified, but survived in captured documents. American fighters have achieved the impossible. Concentrated nose armament eliminates our ship's combat effectiveness faster than our shipyards can replace vessels. May brought the strategic bombing campaign against Japanese naval facilities. P-38 escorts for bomber formations used concentrated armament against shipping targets of opportunity during return flights. The dual capability of air-to-air combat and anti-shipping operations maximized mission effectiveness per sortie. The accumulated destruction was becoming strategically decisive. Japanese destroyer availability had declined by 55% since November 1942. Replacement construction could not match destruction rates. Naval capacity was failing throughout the Pacific, despite maximum industrial effort. June 1943 brought the invasion preparation phase for Operation Cartwheel. P-38 squadrons systematically destroyed Japanese naval forces that could interfere with Allied amphibious operations. The concentrated armament proved ideal for precision elimination of specific vessel types rather than general fleet attacks. The New Georgia invasion on July 5 demonstrated the strategic impact of naval vessel elimination. Japanese surface forces could not effectively oppose the landings because P-38 attacks had systematically destroyed their radar, communication, and fire control systems. Ships remained afloat, but could not function as coherent fighting units. The tactical success of Pacific amphibious operations reflected strategic preparation through naval system destruction. Japanese mobile naval reserves could not respond effectively because their electronic and command systems had been systematically eliminated by concentrated fighter armament. The P-38 had achieved strategic victory through tactical precision. July brought the Bougainville campaign, enabled by continued P-38 operations against Japanese naval forces. The concentrated armament proved equally effective against retreating vessels, as advancing formations discovered their escape routes, monitored by aircraft that could eliminate any ship attempting to interfere with Allied operations. The Rabble offensive succeeded partly because Japanese naval reinforcements could not reach the battlefield effectively. P-38 attacks had destroyed the command and control systems needed to coordinate fleet movements. American forces faced isolated Japanese vessels rather than coordinated naval formations because communication systems had been systematically eliminated. August brought the systematic destruction of Japanese naval aviation support vessels. The concentrated firepower proved devastating against seaplane tenders, ammunition ships, and fuel vessels that required precision destruction rather than general bombardment. The P-38's nose armament could eliminate these specialized vessels with surgical accuracy. September brought the final Japanese naval collapse in the Central Solomons. The destroyer fleet had been reduced to 30% of operational effectiveness through system destruction rather than actual sinking. Replacement electronic equipment production had virtually ceased due to material shortages and factory destruction. American pilots reported increasing difficulty finding viable naval targets. The Japanese surface fleet had been so thoroughly disabled that operational warships became rare sightings. The concentrated armament had achieved what strategic bombing could not: complete elimination of enemy naval effectiveness through precision system destruction. October brought the Bougainville invasion preparation. Japanese naval forces attempting to concentrate for defensive operations discovered that system destruction had made coordinated fleet action impossible. Individual ships retained propulsion but could not communicate, navigate precisely, or coordinate fire control with other vessels. The Battle of Empress Augusta Bay failed for Japan, partly because their naval electronics could not support coordinated action. P-38, destruction of radar and communication systems, meant that Japanese destroyers could not execute the precise night torpedo attacks that Japanese doctrine required. Units operated individually rather than as coordinated formations. November brought the final accounting of naval system destruction. P-38 squadrons had eliminated combat effectiveness of over 200 Japanese naval vessels using concentrated nose armament. The mathematical efficiency was stark. Each vessel disabled required an average of 15 seconds of concentrated fire. The strategic impact extended beyond immediate destruction to systemic operational failure. Japanese naval personnel had been so traumatized by precision system attacks that many refused sea duty assignments. The fleet failed due to personnel shortages, even where equipment remained physically intact. December 1943 brought the final Japanese naval statistics for the Solomon Islands campaign. Vessel operational availability had declined to 25% of requirements, despite minimal actual ship sinking. The concentrated armament of American fighters had achieved what torpedo attacks could not: complete elimination of naval effectiveness through precision system destruction. If you want to see how this incredible precision firepower ultimately decided the Pacific Naval War, make sure you are subscribed with notifications on. The numbers we are about to reveal will show just how completely America revolutionized anti-shipping warfare. The Gilbert Islands invasion demonstrated the ultimate impact of naval system destruction. Japanese surface forces assigned to defend the atolls could not coordinate defensive operations because P-38 attacks had systematically eliminated their command and control capabilities. Ships arrived individually rather than as fighting formations. January 1944 brought the Marshall Islands campaign, unopposed by effective Japanese naval forces, partly because system destruction had eliminated coordinated fleet operations. Individual vessels retained mechanical function but could not operate as integrated fighting units because electronic systems no longer existed. February brought the Truk raid, where P-38 concentrated armament eliminated the effectiveness of the entire Japanese combined fleet anchorage. Instead of attempting to sink every ship, lightning formations systematically destroyed radar, communication, and fire control systems, rendering the fleet operationally useless. March brought systematic destruction of Japanese naval logistics vessels. The concentrated firepower proved devastating against tankers, ammunition ships, and repair vessels that kept the fleet operational. Precision destruction of support vessels achieved strategic effect, equivalent to sinking frontline warships. April brought the New Guinea campaign, where Japanese naval support proved ineffective due to systematic communication destruction. Ships could not coordinate with ground forces or each other because P-38 attacks had eliminated electronic systems required for modern naval warfare. May brought the Marianas invasion preparation. Japanese naval forces attempting to concentrate for Operation A-Go discovered that system destruction had made fleet coordination impossible. The Mobile Fleet retained individual ship capabilities but could not function as an integrated fighting force. June brought the Battle of the Philippine Sea, where Japanese naval effectiveness was compromised before the battle began. P-38 attacks on naval facilities had destroyed replacement electronics and communication equipment. The Mobile Fleet fought with degraded capabilities that contributed to its decisive defeat. July brought the Saipan and Guam campaigns, where Japanese naval opposition proved minimal, partly because P-38 system destruction had eliminated effective coordination between surface vessels and shore defenses. Ships could not provide accurate fire support because precision fire control systems no longer functioned. August brought the final collapse of Japanese naval logistics in the Central Pacific. P-38 attacks had systematically destroyed the communication and navigation systems required for supply operations. Individual vessels could not locate rendezvous points or coordinate with other ships. September brought systematic destruction of Japanese naval training facilities. The concentrated armament proved equally effective against training vessels and shore installations. Japan could not replace destroyed electronic systems because training facilities for technical personnel had been eliminated. October brought the Leyte invasion, where Japanese naval response proved uncoordinated due to systematic communication destruction. The Shogo operation failed partly because individual fleet units could not coordinate effectively with each other or with land-based forces. November brought the final Japanese naval statistics. Electronic system availability had declined to 10% of operational requirements. The concentrated armament of American fighters had achieved complete elimination of naval coordination capability through precision destruction of critical systems. December brought the Luzon invasion preparation. Japanese naval forces could not coordinate defensive operations because P-38 attacks had systematically eliminated the communication infrastructure required for fleet operations. Ships operated as individual units rather than coordinated formations. January 1945 brought the final revelation of P-38 anti-shipping effectiveness. The concentrated nose armament had eliminated Japanese naval effectiveness without necessarily sinking ships. Vessels remained afloat but could not function as warships because critical systems had been destroyed. February brought the Iwo Jima invasion, unopposed by effective Japanese naval forces, partly because system destruction had eliminated coordinated surface operations. Individual ships lacked the communication and fire control systems required for effective intervention in amphibious operations. March brought the Okinawa invasion preparation. Japanese naval forces assigned to Tengo operation could not coordinate effectively because P-38 attacks had destroyed the electronic systems required for modern naval warfare. The operation became a series of individual suicide attacks rather than coordinated fleet action. April brought the final accounting of Japanese naval system destruction. P-38 concentrated armament had eliminated the effectiveness of over 600 Japanese naval vessels through precision destruction of critical systems rather than hull damage. Mathematical efficiency exceeded all predictions. May brought the planned invasion preparation for Operation Downfall. Japanese naval opposition was expected to be minimal because P-38 system destruction had eliminated coordinated fleet operations capability. Individual vessels retained propulsion but could not function as fighting units. August 15, 1945. Emperor Hirohito's surrender broadcast ended the most systematic naval system destruction campaign in maritime history. P-38 squadrons had eliminated Japanese naval effectiveness through precision destruction of critical systems rather than traditional ship sinking. The final accounting revealed the mathematical impossibility of Japanese naval survival. Peak American system destruction. 12 vessels disabled per day per squadron. Japanese electronic system replacement production. At war's end, 0 systems per month. Concentrated firepower had achieved complete strategic victory through tactical precision. The human cost of this destruction campaign extended beyond immediate casualties to systemic naval collapse. Japanese naval personnel, demoralized by repeated system failures, had largely abandoned surface operations, even when ships remained mechanically functional. Conversely, American P-38 pilots emerged from the war with unprecedented experience in precision naval system destruction. The concentrated armament had proven so effective that similar anti-shipping tactics influenced post-war naval aviation development. Precision system destruction became standard doctrine. The strategic implications extended far beyond World War II. The P-38's concentrated firepower demonstrated that naval effectiveness could be eliminated without necessarily sinking ships. Critical system destruction proved more efficient than hull destruction for achieving strategic objectives. Japanese naval architects studying American tactics after the war provided honest assessments of P-38 effectiveness against ships. The concentrated nose armament had achieved destruction, precision impossible using conventional anti-shipping weapons. Every round fired struck critical systems rather than general hull areas. The technology transfer from P-38 anti-shipping operations influenced post-war naval aviation development. Concentrated precision firepower became standard for anti-ship aircraft. The mathematical advantages of focused system destruction over general bombardment proved decisive in subsequent naval conflicts. Modern anti-ship aircraft still follow principles established by the P-38 Lightning. concentrated firepower, precision system targeting, and critical component destruction remain the foundation of effective naval aviation. Japanese distribution of anti-aircraft armament proved inadequate against focused precision attacks. The P-38's naval combat record reflected revolutionary anti-shipping philosophy. Individual aircraft eliminated more Japanese naval effectiveness than entire squadrons of conventional torpedo bombers. Concentrated armament had transformed tactical capability into strategic weapon effectiveness against naval targets. The ship system destruction achieved by P-38 concentrated armament proved more decisive than traditional torpedo and bomb attacks against armored targets. Naval vessels required precision destruction of critical components rather than massive hull damage. The nose-mounted weapons provided surgical precision impossible using conventional naval attack methods. Today's military analysts study P-38 anti-shipping operations as the definitive example of precision naval warfare. The concentrated armament created system destruction densities that eliminated vessel effectiveness through focused impact rather than widespread damage. Quality of destruction proved more important than quantity of destruction. The Japanese naval personnel who survived concentrated firepower attacks carried psychological scars that influenced post-war naval development. Many refused sea duty assignments even after hostilities ended. The trauma of facing precision system destruction created personnel shortages that delayed naval reconstruction. Veterans of P-38 anti-shipping squadrons spoke with professional pride about their aircraft's concentrated naval firepower. They understood that nose-mounted armament had revolutionized ship attack effectiveness. Individual pilots achieved naval destruction levels that entire formations of conventional aircraft could not match. The mathematical superiority of concentrated armament extended beyond immediate naval battle effects to strategic campaign outcomes. The P-38's focused firepower eliminated Japanese naval coordination capability faster than replacement systems could be installed. Destruction rates exceeded repair rates by factors that made recovery impossible. The final irony of the P-38 naval story was that Japanese criticisms of the design proved to be its greatest strengths against ships. The heavy nose that naval architects dismissed as unbalanced provided platform stability for precision anti-shipping attacks. The twin engines that seemed inefficient provided reliability for extended naval patrol operations. Admiral Isoroku Yamamoto's assessment before his death specifically mentioned the P-38's concentrated armament as a critical threat to Japanese naval operations. The focused firepower could eliminate ship effectiveness without the massive effort required for traditional naval destruction. Mathematical precision had proven more important than conventional naval firepower. The American P-38 Lightning of World War II established principles that continue governing anti-ship aircraft design. The concentrated nose armament proved that focused firepower could achieve naval strategic objectives through tactical precision against critical systems. The mathematical concentration of impact defeated distribution of naval defensive resources. When Japanese naval officers first read reports of American fighters with concentrated nose armament, they dismissed the concept as inadequate for naval warfare. By war's end, they understood they had been witnessing not design limitation but design revolution. America had indeed created an aircraft that could saw ships apart through system destruction, and Japan never stood a chance against such focused precision.